In this conversation, we'll be going over some basic SQL concepts and syntax. SQL is a very pervasive language. It is in lots of different places, used in lots of different ways. Sometimes it's used to query a relational database, and sometimes it's used as a language a lot of people either know that do something that's kind of relational in nature. So it is a good thing to know. We're going to go over the five sections inside of Chapter 6 and talk a bit about SQL data definition and data types, talk a little bit about specifying constraints in SQL, basic retrieval queries, insert, deletes, and update statements inside of SQL, and then a few additional features of SQL as well. Basic SQL, it is considered one of the major reasons for the commercial success of relational databases. It's a pretty simple to understand language as part of the reason. SQL has an origin in relational predicate calculus called tuples, which we'll talk about in Chapter 8, which was proposed initially as a language called Square. SQL actually comes from the word SQL, which was the original term used in the paper Sequel to Square by Chamberlain and Boyce. IBM could not copyright that term, though, so they abbreviated to SQL and copyrighted the term SQL, hence the usage of SQL and why some people continue to call it SQL. Now popular known as structured query language. So SQL is quite popular, and that is where the terminology comes from. SQL is an informal or practical rendering of relational data model with syntax, and it does several different things, and we'll go each one of those. Starting off with SQL data definitions and data types and standards. There's some terminology that's always essential to understand. A table, row, and column are used in the relational model terms for relation, tuple, and attribute. Create statements is the main command for creating essentially something that is a data definition. So be it a table, store procedure, or whatever it might be, it starts typically with create. The language has features for data definition, data manipulation, transaction control, indexing, security specifications, active databases, multimedia, and distributed databases. SQL has gone through many standards, starting with SQL 86, and has been refined continually. Later standards are divided into core specifications and specialized extensions. The extensions are implemented for different applications such as data mining, data warehousing, multimedia, and so on. SQL 2006 added XML features. 2008, they added object-oriented features. SQL 3 is the current standard, which started with SQL 1999. It is not fully implemented in any relational database management system. That's one of the concepts about these standards is there's lots of them. Each individual organization chooses what part of the standard to implement. Very few things are actually core to the standard in entirety. They typically implement some portion of it in a certain way that's appropriate for that particular vendor. Schema and catalog concepts in SQL. So basically, we've got some basic SQL syntax, and there are variations of them that are going to be in place for lots of different database management systems. An SQL schema is identified by a name. It includes an authorization, identifier, and descriptors for each element. Schema elements include things like tables, constraints, views, domains, and other sort of constructs. Each statement in SQL should end with a semicolon, although sometimes those are omitted. But generally speaking, for it to be a well-formed SQL statement, it should have the semicolon at the end, though some interpreters are pretty lax with you and let that go by. Create schema statement is typically of the form create schema, company name, authorization, and then whoever should have access to it. There are, again, lots of different variations. A catalog is a name collection of schemas in an SQL environment, so you can have more than one schema in a particular environment. SQL also has the concept of a cluster of catalogs, so that yet another sort of construct of organization. Create table commands in SQL. This is typically used to specify a new relation, provides a table name, specify attributes, types, and initial constraints. Can optionally specify a schema. So a table can also optionally say that it is part of a schema. So create table, schema name dot table name is the basic idea, or you can just simply say create table employee, and it goes within the current or active schema. Base tables or base relations are relations and tuples are actually created and stored as a file by the database management system. Virtual relationships or views, or virtual relations or views. It's essentially kind of like a table, acts like a table, but it's not really a table. Typically created through the use of create view, and then followed by some form of SQL statements, and it does not correspond to a physical file unless it is a materialized view. So here's an example of a relational database schema, and so it gives you a basic idea of how things potentially link together, very similar to things we've talked about in the past. Continuing our revisiting of the material we covered in Chapter 5, this is a database state of a given point in time for the company, which we talked about before, the relational database schema of it. And also some additional parts of the other tables, essentially, that are made up of the state of that database. This is roughly the SQL create table data definition that corresponds to portions of that schema. You'll notice that we're creating a table, so we have create table and then the table name, and then parentheses, a set of columns, essentially, or attributes associated with each one of those items: first name, middle initial, last name, and so on. And also some additional characteristics, including data type and if nulls are allowed or not. Data types may also have a length depending upon the type of data type that's involved. You'll also see down there partway through the screen is references to where there's a foreign key relationship being described inside of the department table. Continuing that schema of tables being created, we have project and works on and dependent, and again containing some primary key and foreign key constraints. Some foreign keys may cause errors, and they could be specified via circular references or because they refer to a table that has not yet been created. So there's several ways that you can get around that particular challenge. One approach is to create those relationships after the fact. The other is to create a table and then create attributes in a certain order, so insert records in a certain order. There are basic data types associated with tables as well. You have numeric data types such as integers, small ints, and so on. Floating point, which are real numbers which have some fractional component, and those are either float or real or double precision depending upon the size of those. Then you typically have some form of character string type data. Sometimes they are fixed length, such as char n or varchar n, depending upon if they're varying length or a fixed length. And you may also have something that indicates that they're essentially double byte characters as well. So if you're storing Unicode values, it may be something other than just char. Bit string data types include things like bit, fixed length, or bit varying in, which is essentially a binary list or array of a certain either fixed or variable size. You have a Boolean data type, which is either true, false, or possibly null, depending upon the settings of the column. Date type, and it could be various elements of it, could include, depending upon the database management system, year, month, and day, and it could also include time, depending upon how it's being managed. There are also date and time fields. These are plus a minimum number of positions for decimal fractions of seconds, sometimes even greater than seconds. And also, typically, there's the concept of potentially time zones associated with dates or some variant of UTC type conversion. So it may either have an offset or it may be the way that the date is represented, but generally there's a way of handling global times. You also have interval data types, which deal with essentially duration or a range associated with a date time sort of construct. And then there's also date, time, timestamp, and interval data types that can be cast or converted to string types for comparison or some means of doing comparison, either natively or through conversion. A domain, as the name used with the attribute specification, makes it easier to change the data type for a domain that is used by numerous attributes. Improves schema readability. For example, create domain SSN type as char 9. It's kind of similar to a UDT. A user-defined data type are supported in object-oriented applications in Chapter 12. They're used through create type. Basic constraints in the relational model has three basic constraint types that are supported in SQL. You have a key constraint, which is a primary key, cannot be duplicated, so it's essentially uniqueness. Entity integrity constraint is a primary key, cannot be null, and referential integrity constraint that the foreign key must have a value that is already present as a primary key or maybe null, depending upon how things are configured. Specifying attribute constraints. Other restrictions are attribute domains. Sometimes you specify a default value so that if a value is not supplied, then it is utilized. Null is not permitted for a particular attribute, so you can say it's not null. Or check, which basically determines if something is within a specified range. So in this case, is it greater than 0 and less than 21? The primary key clause specifies one or more attributes that make up the primary key of a relational relation. So in this case, dint primary key. Unique clause specifies alternative secondary keys called candidate keys in the relational model, and you basically say that it is to be unique. Foreign key clauses are default operations. You reject values in violation. They oftentimes are attached using referential trigger action clauses. They may also include things like set null, cascade, or set default. Actions taken by the database management system for set default or set null is the same for both on delete and on update. Cascade option is suitable for relationship actions. So at the point that something changes, you need to make those take effect elsewhere. Using the keyword constraints is used to name a constraint and is useful for later altering. So you may want to change it at a later time. Here is an example of some default attribute values and referential integrity triggered action specification. Notice that the constraint keyword is present at the table employed partway through near the end, and that's where these things generally occur, is near the end of the table definition. Sometimes you'll use the word check to indicate that a constraint should be applied on a tuple, and this is generally something where you're wanting to make sure values are within a certain range or to be allowed. So the department created date's got to be less than or equal to the manager start date as an example, and they are applied to each individual tuple, so each record independently. The basic retrieval queries inside of SQL start with select, that is the common ones you use, and you select and then followed by some statements or elements of that statement. And it is one basic statement for retrieving information from a database. SQL allows a table to have two or more tuples that are identical in all their attribute values, so there's no guarantee of uniqueness or order. Unlike relational model is strictly set theory based. So multi-set or bag behavior is tuple ID may be used as a key. So sometimes you'll have essentially system managed or generated value that becomes the key. Select from where is the basic structure of most SQL queries. You select something from something where some condition. The select is typically an attribute list that may include aliases. So it is the name of the columns that you're interested in. The table list is where you're getting stuff from. And then there are usually a set of conditions. This is kind of the simplest form of a select query. It can get more interesting than that really quickly. Generally, whenever we're talking about the logical comparison operators, it's usually less than, greater than, equal to, not equal to, and so on. The projection attributes of those attributes which are included in the select statement. So that's what you're trying to retrieve. And the selection condition is the Boolean condition that must be true for any retrieved tuple. It's what's going to be in the where clause. Selection conditions include join conditions where multiple relations are involved. So you may be selecting from a combination of tables and applying logic at that level. So here is some basic retrieval queries. You have the first query is select birth date and address from employee, where first name's John and middle initial is B and last name is Smith. Or you might be doing a similar select below, first name, last name, address from employee and department, where department name is research and department number is equal to supplied number. This is an additional query showing essentially a select off of a joined set of tables. So we're joining together project, department, and employee here. They're doing so by using a where clause to do the joining. There's also a join sort of flavor of SQL that is perhaps a bit more readable than this. But what this is basically saying is that you're joining across where dnum is equal to department num or d number and manager SSN is equal to SSN and the location is equal to Stafford. So basically what you're doing here is for every project located in Stafford, list the project number and controlling department number and the department manager's last name, address, and date of birth. There is a little bit more of a eloquent sort of way of explaining this in additional query constructs. Sometimes you have ambiguous attribute names and you need to distinguish them by applying the table name that goes with them. Probably a good idea whenever you're dealing with joining across tables anyway, because it makes it really clear what D number belongs to. Is it D number is on the employer, or D number is on the department? But it's a good idea to be very clear in your statement. Even if you can get away with not having it, it's probably a good idea because it makes it easier to read the query. So sometimes you can have the same attribute, and that's where it becomes with the same name, and you want to be able to differentiate between the two by specifying the name of the table associated with that attribute. Aliasing and renaming and tuple variables, sometimes you want to be able to select something as something else, and that's literally how it is done. You add the word as after the table that you're selecting from, and it's a way of doing essentially aliases on the table names. You can also do something similar on aliases on the attributes being selected. So you can select a first name or F name as first name spelled out, perhaps, if you include the word as afterwards. It is a good idea to sometimes to use abbreviations and prefixes, but the primary goal of any language, SQL included, is for clarity and readability. So you want to balance the length of the names with perhaps the readability of the queries. Attribute names can also be renamed. That's what I just mentioned. So you can say employee as E and so on. So note that the relation of employee now has a variable name E, which corresponds to the tuple variable as, may be dropped in most SQL implementations, although it's not a bad idea to include it for clarity's sake. You can there's some things that are interesting in the use of wildcards and so on. So if you don't have a where clause, you're basically saying that there's no condition on the selection of the tuples that can result in perhaps unexpected things like a Cartesian product, and that's what this cross product is basically every row and every column combined together. Generally not something we want, although there are times that you will do so. Generally speaking, you want to do a where clause on it, although there are exceptions that you may want just to use it as a way of refining the queries and listing all of the rows. So without a where clause, you will get all the rows that match your conditions, including if you're joining multiple tables. If you use an asterisk, it's a way of saying that you want essentially all columns. There is concern with that sometimes because the use of a wildcard might be simple and easy, and you can also specify which particular table it is that you're wanting to get if you're joining from multiple tables. But the basic idea is that you should probably be listing the columns you're interested in because it can get quite large if you include everything all of the time. SQL does not automatically eliminate duplicate tuples in a query result. You can do so by adding the word distinct. So there are times that you want to get rid of any kind of duplication. So if you, for some reason in your selection criteria, you have something where you may have people with that multiple records that are matching, then you may want to add the word distinct in order to refine that result. There are set operations which you can do, which is union, except, and intersect corresponds to essentially joining things together from two different queries, basically. And you oftentimes you will do the union more than you do most other things. There's union and union all. Then it's about unioning together two result sets that otherwise would come back as two distinct things. But there are other variations, such as the differences between the two and the intersection. Like comparison is used to do some form of wildcard searching. Generally speaking, the percent is used as the wildcard character. So in the example that's on the screen, you have like percent Houston underscore TX percent. So that means that anything that contains that string within it is likely to match. And you can also use the underscore character for single characters most of the time. Again, always double check with your particular implementation of SQL to make sure that it is doing what you think it is doing. Between is often used to do a range. So sometimes it is between two numbers, might be between two dates, could even technically be between two strings, but generally speaking, it is something that includes some sort of range with order associated with it. You can also do some forms of relational operations on columns. So you can do things like addition, subtraction, multiplication, division as part of the select. Sometimes it gets even more interesting than that, depending upon the language and what extensions are available to you. This is a way of getting up with basically adding 10% to the salary to figure out what an increased salary might be for everybody that works on a particular product. You can use order by to control the ordering of results. Again, SQL doesn't really care about order. You may get things back in the same order most of the time. You may not. So in order to ensure that you get it by a certain way, you order it by either ascending or descending by a certain field of interest. And you use the order by to basically say what that order is. And it can involve multiple columns from multiple tables. Descending goes in descending order, ascending in ascending order. And typically they're placed at the end of the query. Most of the time that's required, that it needs to be near the end. So your basic query block, as we've extended it a little bit, we went from just a select from where and added now an order by so that you can order by its list of attributes. And also notice that the semicolon is at the very end. Again, SQL should terminate with a semicolon. Insert, deletes, and updates inside of SQL. This is how you actually are going to insert and manage data. Insert is used to insert a record, essentially a row, inside of a database table. Update is used to change a value of an existing one, and delete removes the record from the table or relation. Insert is simplest form is used to add one or more tuples to a relation. The attribute values should be listed in the same order as the attributes were specified in the create table, or there should be set in such a way that it includes the list of those attributes in the order that the values correspond. Constraints on data types are observed automatically, so you will not be allowed to insert something of the wrong data type. And integrity constraints are part of the DDL specification are enforced. So a typical sort of insert, and this is saying insert into employees, and then it's giving the values. You also have the option in many database tables to include the parentheses employee, parentheses the column names, and then closing parentheses, and then the values. Probably a better approach because this requires you to insert every column versus you may not insert all of them. And this is that example that I kind of just mentioned. Or no, this is showing that you can insert, and it is doing what I just mentioned. It is inserting these column names, these three columns, based upon this selection criteria. So you're inserting from a selection statement, which is a fairly common thing to do. Bulk loading of tables. Sometimes you use insert for bulk loading of multiple tables and rows into a table. A new table, T new, can be created with the same attributes as T and like and data in the syntax, and it can be loaded with an entire data. So for this case, it's saying create table, D5 of imps like employee, and then select a statement and then with data. Some of this syntax is going to get into implementation specific, so that may not work for all DBMS systems that you run across. Delete is how you get rid of things out of the table. This is a hard delete. It physically will not be in the table once you do this. Oftentimes there's this concept of a logical delete, which is used more common. A logical delete, you basically set an attribute that indicates that something shouldn't be really viewed as being present, but you don't actually get rid of it. And that's sometimes done for more tracking purposes and so on. Referential integrity will be enforced whenever deletes are involved. Tuples are deleted in one table at a time, unless cascade is involved, where it will remove those things that are related. A missing where clause indicates that you want to delete everything. So be very cautious of not having a where on your delete, unless that's what you really want to do, and you will not get any prompting. It will just simply delete everything. So might be a lesson you don't particularly want to learn. The number of tuples deleted depends upon the number of rows in the tuples that match the where clause that is used in your delete statement. So the delete command is basically to delete from some table name, where, and some criteria. So in this case, we're saying delete everybody that has the last name Brown, delete everybody that has the social security number 1, 2, 3, 4, 5, 6, 7, 8, 9, and then delete everybody with a department number of 5, or delete all records from employee. So we want to be very cautious of such things. It does enforce referential integrity and will cascade any sort of deletions that are necessary. But again, you want to be very cautious of unbounded deletes. Updates is used to change the attributes of one or more records that already exist in the table. A where clause is used to control which ones are going to be adjusted. Again, failure to include a where clause will result in everything being updated, not just the ones you want to change. You can specify an additional set clause of the attribute to modify, or attributes that you want to modify. And each command modifies tuples in the same relation. Referential integrity is specified as part of the DDL, will be enforced. So here's an example of changing something inside of the project table from, we're basically setting, we don't know what it was before, but we're setting the location to Bel Air, and we're setting the department number equal to 5, where the project number is 10. So I assume we're moving a project from one location to another. An additional example of update: give all the employees in the research department a 10% raise, and we do so by saying update employee, set salary equal to salary times 1.1, where basically using a nested select statement where they're in this research department. Additional features of SQL: you have techniques for specifying complex retrieval queries, writing programs in various programming languages that are included in that include SQL statements embedded in dynamic SQL, SQL CLI, and its predecessor ODBC, SQL PMS or PSM, and so on. There's a set of commands for specifying physical database design parameters, file structures, and for relations access paths, and that's through create index. Transactional control commands specifying the granting and revoking of privileges to users, constructs for creating triggers, enhanced relational systems known as object-oriented relational databases, or object relational defined relations as classes, abstract data types, user-defined data types supported with create type. New technologies such as XML and OLAP are added into some versions of SQL. And in summary, we've talked a bit about what SQL is, how it's used in both data manipulation and data definition language sort of constructs. We talked about creating tables, creating records, inserting records into those tables, updating and deleting those records, querying those records using the select statement. So with that, we've reached pretty much the end of this conversation. As always, if you have any questions about this material, do feel free to reach out and let me know. Again, stay safe, and we'll speak again soon.